Alright, this is supposed to be video 2, but actually video 3 because video 1 was so long. Video 3 of extra examples for lesson 6, precalculus. So, yeah, there's a bug. Goodbye, bug. Sorry. We have x equals 3 cotangent theta plus 2, y equals 2 cosecant theta minus 3 for theta between 0 and pi. This is our set of parametric equations. We want to find the domain and range of the rectangular equation, write the equation for the rectangular equation, and then sketch the graph of this set of parametric equations. Let's get started. Oh, that's the Nemma bear. You coming downstairs, Nemma? Come here. Emma. Come here. Sorry, interruption. Oh, she wants to bark at other things. I don't know why. Here we go. So, in order to find the domain, we look at the cotangent. X equals 3 cotangent theta plus 2. And remember, cotangent is 1 tangent or cosine over sine. Oh, that's cotangent, not tangent. Sorry, cosine over sine. So if we're going to graph this, I'm not going to make the same mistake I made last time. I'm going to go 0 here, and it's plus 2, 1, 2. It's got a stretch, vertical dilation stretch of 3, and we have 0, pi over 2, pi. Remember, we have an asymptote at 0, asymptote at pi. In other words, whenever sine is 0, we get asymptotes. And with 0 here, and the graph goes like that. But no, it doesn't. Sorry, I said I wasn't going to make the same mistake. I made the same mistake. The same mistake I made last time. Sorry, the graph goes like this. Power 2. It would normally go through 0 right there, but we got this upper shift up 2, so it goes like that. It's got the stretch of 3, but we don't worry about the exact shape. There we go. So here, this is theta, this is x. So x is between, so when theta is between 0 and pi, we get this asymptotic behavior, and we get all the x's. So here we get all real numbers. So domain is all real numbers. Now let's look at the range. The range is going to go with this 2 secant theta minus 3 equals y. So once again, we're going to graph here. This is our theta axis. This is our y axis. We go 1, 2, 3, negative 3. And we have down to, up to. So we're bounded. Sorry, if this was a sine or cosine function, it would be bounded between -1 and -5, but it's a cosecant, which is 1 over sine. So I'm just going to graph in pi over 2, pi, so on. Right, it would look like this. Like that. Well, we have our asymptotes. Every time that sine function hits the midline, we only care about between 0 and pi, so it's here from -1 and larger. So here it's all the y's that are greater than or equal to -1. Because we get this part of the graph between 0 and pi, we have this bounded by those asymptotes just going up. Lowest is at -1 right there. Wonderful, we have our domain and range for rectangular equation. Now let's find out what that rectangular equation is. In order to do that, we need to eliminate this theta variable. Because we have this cotangent and cosecant, we can't just solve for theta and then plug it in and like magically make it disappear. We could, but it would be a really not so fun looking equation. We could make a beautiful equation by remembering our Pythagorean identity. So, looking at our Pythagorean identity, we know sine squared plus cosine squared equals 1, right, theta, theta. Right, each of these cotangent, cosecant have a sine squared in the bottom, or sine on the bottom, so we're just going to divide everything by sine squared to get 1 plus cotangent squared theta equals cosecant squared theta, and then subtract the cotangent squared theta minus cotangent squared theta to get 1 equals cosecant squared theta minus cotangent squared theta. So it's similar to that last example I did on the video that went long. Okay, so hopefully you've got an idea of what this graph is going to look like going off of that. Now what we want to do to actually make it look in the rectangular equation, we're going to solve for cotangent theta, solve for cosecant theta, square them both, replace them in that equation. Here we go. So we know x equals 3 cotangent theta plus 2. We're going to go minus 2, and then we're going to divide by 3. So x minus 2 equals 3 cotangent theta divided by 3. So x minus 2 over 3 equals cotangent theta. We're going to square both sides. Square the x minus 2, square the 3. Do the same with the y's. We have y equals 2 cosecant theta minus 3. We're going to add the 3 because we're solving for cosecant theta. Y plus 3 equals 2 cosecant theta. Divide by 2, divide by 2. Y plus 2, y plus 3. Almost made a mistake there. Y plus 3 over 2 equals cosecant theta. And we want to square it, so square the cosecant square the cosecant theta, square the y plus 3, square the 2. So now cotangent squared theta is x minus 2 squared over 9. We can replace that. And cosecant squared theta is y plus 3 squared over 2 squared. So our rectangular equation is, so the rectangular equation is cosecant squared theta minus cotangent squared theta equals 1. So it's y plus 3 squared over 4 minus x minus 2 squared over 9 equals 1. There it is. Lovely. So we notice that is the graph, or that's the equation for hyperbola, right? Because it's got subtraction. And it's a vertical transverse axis because the y part is positive, we're subtracting the negative part. And we got a value of 2, b value of 3, we got a center. Right, we can write in some important info. The center is at negative 3, 2. Let's look at the vertices. The vertices are going to be up and down, but we remember that the range is only y is greater than or equal to negative 3. For hyperbola, the center is not actually part of the graph. It's not something that we actually graph, so don't worry about that part. But we're only going to get the vertex above the center here, because we only want the y values that are greater or equal to negative 1. So the vertex that we care about, which we can just vertex instead of vertices, we're going to go negative 3 plus 2 plus that a value, so negative 1, 2. Alright, we can find the focus later. Alright, focus, we'll do that later. Let's go ahead and sketch in the graph. So, to sketch in this graph, we know we're at negative 3, 2. So, oops. Oh my goodness. Did you find it? Did you see my mistake? I made a mistake. Some of you made this mistake as well. I'm going to dial it back a little bit. Where's my mistake? Find it, if you haven't found it yet. Okay, here it is. See, it's y plus 3. So the center's not a negative 3, 2, because the y part is negative 3. So it's 2, negative 3. Oh, I goofed. 2, negative 3. And then we're adding 2 to the y number. So it's 2, negative 1. Oh my goodness. So 2, negative 1. Yikes, that was close. I almost graphed it wrong. So make sure when you're doing this, if you goof up like I am, so I'm just having a goof up day, that you're checking your work as you go along now. Alright, so 2, negative 1, so here we are, got that, we've got that, so 1, 2, negative 1, that's a vertex, negative 3 is the center, this would be our other vertex, but we're not actually going to graph that. What we're going to do is we're going to use it to create our asymptotes. So 1, 2, 3, b value is 3 because b squared is 9. So 1, 2, 3, 1, 2, 3, right? Basically making this little rectangle. And then we draw the asymptotes. So that's an asymptote. That's an asymptote. And we're only going to do this positive, sorry, not the positive, the upper part of this graph, because we only want the y's that are greater than or equal to -1. So when I sketch in my actual graph, I start here at that vertex and I go up along that asymptote, up along this asymptote. I'm going to get rid of those arrows though. Why am I getting rid of those arrows? Because this is a parametric function. Sorry, it's a set of parametric equations. It is a plane curve. Plane curve means it's got direction. It has a starting and an ending point. Here, because it's asymptotic, right, we have no actual bounds on our x's and y's. It just has a direction that it is going. So we're going to look when theta is close to 0, starting, we have positive x's, we have positive y's. When theta gets close to pi, we have negative x's, positive y's. So here, actually, our graph is going this way. We're going positive x's down to negative y's. Oh, sorry, positive x's to negative x's. Those are all x's there. And then here we got positive y's down into the negative y's, and then positive y's again. There we go. So this curve, this plane curve at 0 starts all the way over there. So as we go like little bits for theta, like 0.001, we're like really big x number, really big y number. And then we come this way as we get close to pi over 2. Pi over 2 would be right here, right? Pi over 2 is at the -1, 2. And then as we go past that pi over 2, for like pi, toward pi, the x's are going to go negative eventually, right? Because we're here, x's are negative, and those y's are going to come back up positive. There we go. Cool. So that's it. The focus, we could find the focus. It's going to be up here somewhere, because it's going to be 9 plus 14. Remember, it's a squared plus b squared. 9 plus 4 is 13. So it's going to be 2, -1 plus square root 13. So square root of 13 is like a less than 4. So 1, 2, 3-ish, about there. That's going to be a focus right about there. Okay, lovely. Oh, we should write the equations for the asymptotes as well. Right, equation for the asymptotes. I've got my Nemoline here barking, which is accenting all my statements. She didn't do it that time. Alright, so it's y plus 3 equals slope. The slope here is up to, because the a value is on the y, so it's going to be up to right 3, so it's 2/3 times x minus 2, and y plus 3 equals -2/3 times x minus 2. Lovely. Okay, so that's example 1. Hopefully that helps you with some of the problems. If you are struggling, hopefully that was a little bit easier to follow than the last video, because the last video was a little bit of a train wreck. I apologize for that, but it is Sunday night and I need to get this ready by Monday. So I'm going to erase this to do example 2, and hopefully, well, hopefully it's good enough. And I mean, let's be real, it's like distance learning. You get to see, like, remember when we were in class and I made mistakes all the time, and you got to see me like, oh, oops, that was wrong, and I'd fix it, and it's just like that. It's just you're not here to laugh at my goofs. You laugh at home at my goof-ups. At least I hope you're laughing, not just shaking your head. All right. Here we go, one more example, and then we're good, and then we're all done. Lovely. So we got x equals... These ones have to shake them to get the ink going. Hopefully you can hear that. 2 plus 5 cosine theta. And then y equals 3 sine theta minus 5. And we have pi is less than or equal to theta less than or equal to 2 pi. Wonderful. Okay. So, start again, we're going to find the domain. Start with the domain, we're going to look at these graphs. So, looking at that graph, we've got here, we've got a midline of 2 and an amplitude of 5. So, 1, 2, 1, 2, 3, 4, 5, that's 7 is x and that's theta. 1, 2, 3, 4, 5. That's negative 3. Excuse me. And we go pi over 2, pi, 2 pi. Right, if it's cosine, it goes maximum, midline, minimum, midline, maximum. So really, we want this part of the curve, which means we get all of the x's, right, from pi to 2 pi. So we're going to get our x's from negative 3 to 7. Yeah. Because we're from pi to 2 pi. Yep, so here, x the domain, the x's are from, where are we at? There we go, negative 3, less than or equal to x, less than or equal to 7. Lovely. Alright, let's look at the range. The range is looking at the y, so we need to graph our y to theta. We've got theta there. 1, 2, 3, 4, 5, negative 5. We've got an amplitude of 3, 1, 2, 3. So that's negative 2, 1, 2, 3, negative 8. And we go pi over 2, pi, 3 pi over 2, 2 pi. 1, 2, 3, 4, 5. Draw on a little guidelines there to help us out. So we go midline, maximum, midline, minimum. Oh, midline, minimum, midline. So the graph looks like this. The part that we want is right here. We just want this part right there. Right from pi to 2 pi. So that's from negative 5 to negative 8. So here the range is negative 8 less than or equal to y less than or equal to negative 5. Wonderful. Okay, so we got a domain and range. Limited, right, is only part of each curve. Now, let's go ahead and look at the rectangular equation. That's what's next, rectangular equation. So here we got cosine and sine. We got to use our beautiful Pythagorean identity because it would be just a mess if we went like minus 2 divided by 5 cosine, arc cosine of that. So 3 sine, arc cosine, blah, no thank you, rather not. So we're going to go, we know we have cosine squared theta plus sine squared theta equals 1. So here we get, solve this for cosine, so x minus 2 divided by 5 equals cosine theta. Right, subtract the 2, divide the 5, and square it. Squared, squared, squared. Here I get y plus 5 over 3 equals sine theta. Nope, just sine, we haven't squared it yet. Right, add the 5 divided by 3, and then we're going to square it, square it, square it. So, I got my cosine squared, I got my sine squared, I can pop them in, and go from there. Here we go. Let's go with the white one again. Kind of shows up the best. Pink shows up really well too, actually. So here we go, we've got x minus 2 squared over 25 plus, right, 5 squared is 25. Y plus 5 squared over 9 equals 1. What kind of graph is that? Go ahead and answer. What kind of graph is it? You're right. It's a graph of an ellipse. But this one's tricky. It's a rectangular equation. For the graph, we need to make sure we're staying within our domain and range. So our thetas are between pi and 2 pi. Or in other words, the x's are between negative 3 and 7, and our range is between negative 8 and negative 5 is where our y's are. So let's go ahead and go about graphing this. So here we've got a center. We'll go ahead and say our important information. So the center is going to be at 2. Notice that's the 2 with the x, not with the y, it's 2. And then negative 5. Right, and then we'll go from there. Right, the a value is going to be 5, right, a equals 5, b equals 3, this is x and y direction, so it's x direction, y direction. Okay, so 2, negative 5, here we go. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Oh, 1, 2, 3, negative 3. 3, 4, 5, that's negative 5, there's the center. And I know my y's need to go from negative 5 to negative 8. And my x's I know go from negative 3 to 7. So that's why I do my graph like that. So now I'm going to say, well, let's look at this. My x's, when theta is pi, my x number's at negative 3, right? Pi negative 3. So I got negative 3. So here I got like theta, x and y. When x is pi, sorry, when theta is pi, x is at negative 3 and y is at negative 5. So negative 3, negative 5. That's my starting point right there. And then here, if I go to like, let's just say 3 pi over 2, right there, my y is at negative 8, right there, negative 8, and my x is at 2. So here is right there, and then if I go to pi, right, pi, I'm at negative 5 for my y, and I'm at 7 for my x. So it's right there. So what I'm getting here is I'm getting half of an ellipse. I'm getting the bottom half of the ellipse. So it looks like that, and it's going this direction. Remember, this is just the center. If it was the full ellipse, in other words, if I went from 0 to 2 pi, I'd go all the way around starting here, but I didn't start at 0, I started at pi, which is kind of the tricky part. So that's the tricky part with that graph. We can throw in the rest of the information. Here we've got, right, a center, we've got the vertices. Vertices are at negative 3, negative 5. We've got 7, negative 5. And we only have one co-vertex at 2, negative 8. Because we don't get the other co-vertex up here, because that's the part that we didn't graph, because that would be when theta would be pi over 2, which we don't have that. It's at theta equals 3 pi over 2, that is our co-vertex. So hopefully that helps you with the other examples. I believe that's all we need. Oh, the focus. We can put the foci on there, sure. Right, just as a reminder, it's 25. Right, c squared equals a squared minus b squared, so c squared equals 25 minus 9, which is 16. So c equals 4. So we go 4 left and right. So instead of 5, it'd be 4, so it'd be like here and there. All the foci will be at 2, excuse me, negative 2 and 2. Oh my goodness, I'm trying to go too fast and I'm goofing here. I'm goofing things up. I'm just making a mess of stuff. Sorry. It'd be at negative 2, negative 5, and it'll be at 6, negative 5. That's where those points are, right? Just look at my graph, right? No. Okay, so that's it. That's all, folks. Hope you enjoyed the video. Have a lovely week. Hopefully the sun is shining like it was this weekend. Remember, office hours, if you have questions, email me, that sort of thing. You're awesome. Keep being great.